cubed of the champagne was titrated with 0.1 moles per decimeter cubed, slight error in that printout there, didn't need to be a minus, of the sodium hydroxide. So our sodium hydroxide is an alkali. Use the results below to calculate the concentration in moles per decimeter cubed of the acid in the champagne. So we're going to treat the champagne as if it were the acid. Assume that 1 mole of sodium hydroxide reacts completely with 1 mole of the acid, so this means we have got a 1-to-1 reaction there. Let's see what the tasks are actually asking us to do. Fill in the bottom row of the table by calculating the overall titer for each trial. Okie dokie, this is just a case of getting your final titer minusing the initial. So 14, 27.9 minus the 14 is 13.9. This will be 13.6, 13.5, 13.6 again. Oh, and a random one there of 12.2. Define concordant results. Concordant results are results that agree to 1 decimal place. For example, 1.2 and 1.3, they're only 1 decimal place apart. That makes sense. If I said 1.5, well, that is 2 decimal place. That is 2 larger than. That is 0.2 larger than that. That does not agree to the 0.1 decimal place. That would be a better way of putting it. Sorry about that. So results that agree to 0.1 of a decimal place. So there we are. The reason though we need concordant results is because concordant results are used to calculate the titer. We do not use the non-concordant results. So with these two, they agreed to 0.1 decimal place there, but that one didn't, so we would ignore that one. So task number 3, use the concordant results to calculate the mean titer. Okay, let's have a look at those results. Let's get rid of the ones that are not concordant. They agree with each other, however we don't tend to use the rough titer, so I'm going to ignore that one there. That's 0.3 apart, so they're not concordant to each other. These ones are 0.1 apart, they are concordant to each other, therefore so is that one as well. So that one is miles out, complete anomaly there, goodness knows what happens there. That one is comparable but is not concordant, so we are going to ignore that. So the mean titer, therefore, is going to be 13.6 plus 13.5 plus 13.6, all divided by 3 because there's 3 values there. That's how calculating averages works. And that gets you 13.56 recurring. Use the answer from part 3 to calculate the concentration of the acid found in the champagne. Okay, just like we talked about in lesson, what I'm going to do is I'm going to go back to the question and pick out the key bits of information. Now in lesson when we did this, we did a balanced symbol equation first. Here we're not going to worry about the balanced symbol equation because quite frankly you do not need to know the chemical formula of champagne. We're just going to talk about it in terms of it being an acid. So the acid to alkali was 1-to-1, so we might as well just put that in there to remind us. So we've got the acid here and the alkali here. And there is a 1-to-1 relationship there. Let's find what other facts that we know. We've got 25 centimetre cubed of the champagne titrated with the titrated. So the champagne was the acid there, so the volume of the acid is 25 centimetres cubed. There it is, 25 centimetres cubed. What other information have we got there? The concentration of the alkali is 0.1 moles per decimeter cubed. So I just like making a little list here. Concentration, number of moles, volume, concentration, number of moles. Can be done in any order you like there. So the concentration of the alkali, the sodium hydroxide, was 0.1 moles per decimeter cubed. The number of moles is what we're going to have to try and get. We do need one more number here to work with. We're trying to get to the final concentration here. The volume of our alkali used was our average titer there. So our volume here is 13.6 centimeter cubed. Now, because your units for concentration are in decimeter cubed, we also have to convert these concentrations to decimeter cubed, and we do that by dividing by 1,000. So 0.025, and that's decimeter cubed. I've just switched pen here. I've gone to a black pen. The blue bits are the ones that I got from the question. The black ones are going to be alterations that I have made to those original numbers and calculations that I have done. So I've calculated here, gone to from centimetres cubed to decimeter by dividing by 1,000. I'm going to do the same over here as well. That needs to be in decimeters cubed. So divide that by 1,000. We're going to get 0.01356 decimeter cubed. Number of moles, our formula triangle is concentration is number of moles volume. There it is. So to get my number of moles here, I do just need to do the concentration multiplied by the volume. So that's my 0.1 multiplied by the 0.01356 recurring decimeter cubed, which just moves the decimal place along one. So 0.01356 is your number of moles. Earlier on in the question, it did say that it is a 1-to-1 ratio between the alkali and the acid. So if I have 1 mole of this, I'm going to have 1 mole of this. If I have 5 moles of this, I'm going to have 5 moles of this. However, what I actually have is 0.001356 recurring moles of this. So I'm going to have 0.001356 moles of this. So that number just goes straight up there, 0.001356 recurring number of moles. To get back up to this concentration, I do number of moles divided by volume. I haven't left enough space there, so I'm going to do it down here. It's concentration, number of moles over volume. So my 0.001356 recurring divided by my volume of my acid, 0.025 decimeter cubed. Type that into the calculator, it comes out at 0.05426 blah 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 blah. There's quite a few other numbers there in your calculator. I'm just going to report that to, let's go 3 significant figures. In the question it's reported to 3 significant figures, 1, 2, 3, so let's report it to the same degree of precision there. So let's go 0.054, that's the 6 there, so we're going to have to round that up, units of moles per decimeter cubed. 3 significant figures. Job done. That is the worksheet that you were given in the calculations workshop, and it is all completed there. If you did have any troubles with this, please do pop in and let me know, and if there are any other calculations that you would like, please do just email me.